start the PowerPoint here. Here we go. So today what we're going to be talking about in class is water and macromolecules and chemistry. And could you please enter through the back door if you're going to come in? Okay. Okay, well then we will go fix this. So what we're going to be talking about in class today, a little bit of what we talked about last time. Get this to stay open. They don't have a... Yeah, that'll probably work. Can you pass me a chair, please? Thank you very much. Good to know I recorded all of that, right? So the last time we were in here, we talked about what is science, what is biology, how does the scientific method work, and then talking about experiments and how they are empirical or testable, theories, hypotheses, controls, variables, and the placebo effect. So if you missed any of those things, take a look at the PowerPoint from last time. Finishing up in Chapter 1, there's only a couple of slides from Chapter 1. First of all, we talked about what is pseudoscience, where something sounds scientific, but it's not actually supported by trustworthy methodical scientific studies. And so then something that we didn't talk about last time is anecdotal observations. So these are based on only one or a few observations. So this is kind of the idea of where somebody says, oh, I believe that this happens, and somebody says, well, that didn't happen to me, or that did happen to me. So based upon one or a few observations. This happened a lot in the vaccines and autism debate, where we had people who believed that their children were getting autism because of vaccinations, but that was not actually supported by the science. So here's an example of something that would be pseudoscience, where you may have heard the claim in television commercials or online where they say, 4 out of 5 dentist surveys recommend sugarless gum for their patients who chew gum. So when I hear this statement, I think, okay, dentists prefer you to chew sugarless gum. But if you start to break this down and ask why this actually is, who is the person that surveyed all of these dentists? How many of the dentists were there that were surveyed? Did they survey 5 of them, or did they survey 10,005 of them? How do they know that, and for what reasons? Would they recommend that you not chew gum at all, or would they recommend sugarless gum, or does that one recommend sugary gum, and why does he do that? So this statement sounds scientific, but it's not actually based on science. It might be factually true in this one circumstance, but in general relationships, it may not turn out to be what it is on the surface. And so that would be pseudoscience, and it's often used to mislead consumers. An anecdotal observation, like I said, about vaccines and autism, it may not include a sufficiently large enough or representative set of the observations of the world. When looking at vaccines and autism, maybe they did this study in one country and not our country. Maybe they did it with one racial group, or maybe they did it with only one gender. Maybe they only tested, in the case of this vaccine experiment, the doctor only tested 12 children, and there were 6 of them that had autism out of the 12 that he tested. And so that's not big enough, that's not an expansive enough study to actually make the claim that vaccines cause autism. What we like to use, of course, in science is data, and data that's representative of the entire population, and things that are done, hopefully, through controlled experiments that are double-blind and use a placebo. So this can often cause these huge stirs or these huge crises, but may not actually be true. If you hear somebody say, well, this happened to my brother's girlfriend's cousin one time, it's not going to be as reliable as an actual scientific study. So a few important themes that tie together the diverse topics that we see in biology. The two unifying themes that we see in biology are, one, a hierarchical organization, and two, the power of evolution. Everything that we discuss in biology can be organized in a hierarchical way, like you may have heard of the kingdom, phylum, class, genus, species. Kingdom, phylum, class, order, family, genus, species. Trying to remember them in order. And that the power of evolution, very simply, that they change over time. That you go back to your parents, and then your grandparents, and then your great-grandparents, going back over hundreds or thousands or millions of generations, we're going to see that things change over time. So here is a great example of that. If you look at what he's doing, he's got these bug collections that you may or may not have done as a child, and he's comparing, like in this case, the beetles, in this case, the arachnids, in this case, some different butterflies. So if you're going to be literate in biology or understand biology, we have to understand, one, how everything is related, and two, how everything changes over time. And those are central themes to biology. So the four chief areas, like what I talked about, we're going to talk about in this class over the course of the semester. We'll talk, first of all, which is what we're doing right now, the chemical, cellular, and energetic foundations of life. And then number two, the genetic evolution and behaviors of individuals. Number three, the staggering diversity of life and the unity underlying it. If you go back to that picture of the insect collections, you can see that there's a staggering diversity. It's not just one type of beetle when we say beetle. The beetles are some of the most expansive and diverse forms of insects that we have out there. Ecology, the environment, subtle and important links between organisms and the world that they inhabit. So that will round out Chapter 1.